Voyager 1 probe, 35 years and 11 billion miles away from Earth, around 122 astronomical units. While the Voyager 2 probe is 11 billion miles away from Earth, it originally launched in 1977 to study the outer solar system and interstellar space beyond the Sun's heliosphere. Welcome to the Space Wind YouTube channel. In this video, we are going to talk about the Voyager spacecraft in interstellar space. So before starting this video, like this video and subscribe to our YouTube channel for future updates. Since 2004, the 1,600-pound probe has been traveling in a subsection of the outer heliosphere, the heliosheath, where the solar wind slows down in response to pressure from the interstellar medium. After crossing the threshold of the Sun's atmosphere, the probe made its way among the stunning views of our solar system and captured close-up details of the planets Uranus and Neptune, and many details of the solar system. Scientists were amazed. Unlike Jupiter and Saturn, planet Uranus is not visible to the naked eye. On November 4, 1985, Voyager 2's encounter of Uranus began. Activity built to a peak in late January 1986, with most of the critical observations occurring in a 6-hour period in and around the time of closest approach. 11 new moons of the Uranus planet have been discovered, and it took the first thermometer reading for the planet, which is considered the coldest in our solar system with a temperature of 353,213 degrees Celsius below zero. Voyager 1 probe was the first to be raised by Jupiter and Saturn. The images Voyager once sent back have been used in school books and by many media outlets for a generation. And it sent images of the Jupiter planet and its moons that revolve around it, showing the presence of lightning strikes and the presence of volcanoes in one of its moons. It reached the closest point in its path to the planet Saturn, which is marked by a giant circular arc surrounding it. Before their historic crossing into interstellar space, Voyager spacecraft has already served humanity well, taking advantage of the rare alignment of planets in the outer solar system. 9 years ago, the Voyager 1 spacecraft left the solar system, crossing the boundary that separates our solar system from interstellar space, and it is the first spacecraft to reach interstellar space. Interstellar space begins where the Sun's continuous flow of material ceases, and its magnetic field ceases. Richardson said the search results for Voyager 2 are an imaging result in that the boundaries of the region in which the solar plasma spreads are very thin, so the Voyager 2 probe crossed them in less than a day. And this means that the thickness of those border clusters is estimated at about 0.06 astronomical units, which is equivalent to about 8.97 million kilometers. Voyager 1 discovered the intensity of the cosmic rays, and the galaxy suddenly jumped. The concentration of solar particles decreased, and the strength of the magnetic field doubled to about 0.4 nanotesla. 4 more inflection points occurred over the following month, marked by a decrease in field strength. The Voyager 1 probe detected changes in magnetic field intensity 5 separate times, NASA explained. The behavior of the Sun's magnetic field at the heliosphere edge is highly uncertain. Voyager 1 spacecraft detected fluctuations in the field but not at the same time that it detected the change in cosmic ray abundances. The Voyager 1 probe oriented through the outer solar system measures the magnetic field, moving the needle on a compass with cardinal directions provided by the ibex ribbon. The Voyager 2 probe discovered unexpected diversity. Unlike the rocky inner planets Mercury, Venus, Earth, and Mars, the outer planets are giant bodies of gas and liquid with no solid surfaces. The inner planets of Mercury, Venus, Earth, and Mars are called terrestrial planets. As we know, the terrestrial planets have secondary atmospheres. This means that the atmosphere was not formed during aggression but through volcanic activity or comet impacts. Most of the volcanic features discovered within the solar system formed millions of years ago. There are at least 5 known bodies in our solar system with active volcanic activity, and these 4 known bodies are Earth where we live, Io, Jupiter's moon, Triton, Enceladus, and Venus. The Venus planet is the world next inward in orbit around the Sun and is the hottest planet in the solar system, very similar to Earth in size and density. Its surface is a mosaic of volcanic features from peaks to plains shaped from eons of roiling activity. It has an atmosphere 50 times denser than Earth and average surface temperatures of 470 degrees Celsius, 878 degrees Fahrenheit, hot enough to melt lead. The largest volcanic outpourings are the huge lava fields that cover most of the rolling plains. Volcanism on Venus planet shows fewer eruptive styles than on our Earth. Researchers discovered all volcanism on Venus seems to involve fluid lava flows. There is no sign of explosive ash-forming eruptions on Venus and little evidence for the eruption of sludgy, viscous lavas. The Voyager mission cruised toward the outer planets. Scientists predicted that the spacecraft would find moons like our own. Astronomers recently found a second plausible candidate for a moon outside our solar system, called Kepler 1708b. Kepler 1708b is slightly smaller than Neptune, orbiting a Jupiter-sized planet around a Sun-like star, and unusual this examined filter is smaller than the previous filter Kepler 1625b. While these two discoveries retain their candidate status, they end the possibility that large moons like these may begin to appear in the James Webb Space Telescope or plate of data. Kepler 1625b is located some 8,000 light-years away, about the size and mass of the Neptune planet, and orbiting an exoplanet up to several times the mass of Jupiter. Kepler 1625b could be habitable even if the scientists thought the current equilibrium temperature is 350 Kelvin without considering any albedo. It's been 45 years since the Voyager's mission commenced with the launch of Voyager 1 probe on September 5, 1977, and the Voyager 2 spacecraft launching 2 weeks later. Voyager will be remembered as one of the greatest achievements in exploration, where no spacecraft or anything else touched by human hands has ever gone before. The Voyager 2 and Voyager 1, now in interstellar space, there's literally nothing for them to encounter. There are no plans for them to make any encounter, and most of the experiments have been shut down to save power for the radio's transmitter. NASA expects to lose contact with both of them in about 5 years' time. So, you